Welcome to Math with Mrs. Bibb. Today we will be solving polynomials by graphing. The solutions of the graph are still the x-intercepts. So in that first blank we're going to write x-intercepts. And I'm going to put it like this because it could be possible that there would only be one x-intercept. So there could be just one solution. The solutions are also called roots or zeros. So don't forget all those same words. And zeros can either be spelled with an ES or just with an S. So whichever way you want to spell it is fine. I usually add the ES, I don't know why. And then the equation must equal 0. So you have to make sure one side of your equation is equal to 0, and then use Desmos to solve. Oh, whoops. Use Desmos to solve. And it says in your textbook that if it's necessary, so do write this down please, if necessary, round to the nearest hundredth, which is 2 decimal places. So if you get a decimal, do round to the nearest hundredth when you're solving by graphing. So we're going to make it equal 0 first. We're going to add 4x cubed. You might want to pause this video and write down the example. I'm pretty sure there's blanks on your paper, I think. But anyway, write down x to the 4th plus 3x squared minus 5 equals negative 4x cubed. And then I'm going to put that in its proper place. So I'm going to add 4x cubed there. So I have x to the 4th plus 4x cubed plus 3x squared minus 5 equals 0. Now I want to tell you a couple things that I know about this. First of all, this is a quartic function because it's to the 4th degree. I do know the end behavior is, since a is positive, as x approaches positive infinity, this end will point up, and as x approaches negative infinity, that other end will also point up. The ends will point in the same direction since it's an even degree. So I'm going to grab Desmos, and we will graph that equation. I thought I clicked open the graphing calculator. Hold on. There we go. So I'm going to graph x to the 4th plus 4x cubed. Hold on. I have to move it back and forth. I'm so sorry. You'll probably be able to graph it and find the answer faster than me. I think it said plus 4x cubed. Then, yes, plus 3x squared minus 5. And again, I'm not putting the equal 0 in there. And as you can see, I was correct about the end behavior. Both ends are pointing up. And my x-intercepts appear to be negative 3.22 and 0.84. So negative 3.22 and 0.84. I can move this down, I think. Hold on. Yep, so my solutions are negative 3.22, comma 0.84. Those are the solutions to that first example. Now moving on to that next example. If you'll take a moment and read the word problem. Okay, the first thing that we're going to do is we're going to remember the formula for volume of a rectangular prism, and that is length times width times height. So I'm going to use that to write a polynomial. The first thing we have to consider is the fact that it tells us in the problem that each penguin has to have this many cubic feet of water. So we want a pool for 5 penguins, 5 emperor penguins. So I have to multiply 217 times 5. So I want it to be 1,085 cubic feet. My volume, the V here, is going to be 1,085 cubic feet. And that's going to equal the length times the width times the height. So my length is going to be 2x plus 3. Oops. My width is going to be, I guess really the length should be 5x minus 2. It doesn't really matter. I'm going to put 5x minus 2. And then the height is 2x. Now I am going to distribute my 2x here to this first one. So 1,085 equals 2x plus 3 times 10x squared minus 4x. Then I'm going to distribute 2x times both of those and positive 3 times both of those. Going to distribute. So 2x times 10x squared minus 4x plus 3 times 10x squared minus 4x. So 1,085 is going to equal 20x cubed minus 8x squared plus 30x squared minus 12x. And then I'm going to combine like terms. So 1,085 is going to equal 20x cubed plus 22x squared minus 12x. Now, like we did in one of the previous problems, we're going to write a system of equations from that one equation. I'm going to set the left side equal to y and the right side equal to y. And I'm going to go grab Desmos and type this in, and I'll show you my result in just one moment. Okay, I have it typed in. I'm going to go to my tools, and I'm going to make my x-axis be from 1,084 to 1,086. That way I can see, oh, not my x, my y. Oopsie. See? I don't need very far. I'm just going to make it 0 to 10. Oh, see, I was on the wrong one again. 0 to 10. And I want my y, because y equals that. See, I make silly mistakes here. So 1,084 to 1,086. Now this should help me see what I need to see. Okay, where does the line cross the parabola? They're at 5.85, 1,085. And I made a mistake there because that's not the correct answer. That should be 20. So that should help. All right, so 3.5, 1,085 is the answer. And my solution is going to be the x-coordinate of the intersection. So 3.5 is my answer. I'm going to pause and take away Desmos so we can actually see. Okay, I'm going to have x equals 3.5. And what we're going to do now, I'm going to go to the up top right above my picture here. I'm going to move my picture over too so that I can write. We want the dimensions. What would be the dimensions of the pool to meet the requirements? So we're going to substitute 3.5 into my, into my height, length, width, whatever you want to call those. So 2 times 3.5 is 7 feet. And 2 times 3.5 plus 3 is 7 plus 3, which is 10 feet. And 5 times 3.5 minus 2 would be 17.5 minus 2, which is 15.5 feet. So I'm going to write that in words. The dimensions, if you need to write on the back of your paper, that's perfectly fine. The dimensions of the pool should be, I'm just going to put them in the order I have them there, 7 feet by 10 feet by 15.5 feet. And that's my final answer here. And we got that by graphing with Desmos and then substituting into the dimensions that are there. Have a wonderful day.